Hello, good day. Welcome to another episode of our class. And today we are going to be discussing organic chemistry, specifically naming of alicyclic hydrocarbon. So when we talk about alicyclic, from the word cyclic, I want to believe you still remember from our previous classes that when we talk about cyclic, we are referring to compounds that they are in form of a shape, like they are cyclic in nature, so they are in form of a shape. So today we are going to be dealing with first part of it, which is called alicyclic, and then the other ones are the aromatic. So let's first deal with the alicyclic first. So basically we could have compound like this. It's in form of a shape. It could be like this. Even it could be like this. All these are example of alicyclic compound. But you see each of these points here, each of the points in the shape, it represents carbon. So at this place now we have carbon with H2. Here we have carbon and H2. And here we have carbon and H2. So by default, you can still write it this way. CH2, 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 and CH2. However, for convenience's sake, it is always written this way without any carbon or hydrogen. So the moment you see any shape like this, please take note. At each of the points, you have carbon with 2 hydrogen. So the same thing goes for here too. You have carbon and 2 hydrogen here. Here you have carbon and 2 hydrogen. So also this place, you have carbon and 2 hydrogen, and here we have carbon and 2 hydrogen. I want to believe that is clear. So in this compound too, you might be asked, how many carbon do we have here? Of course, we have 6 carbon. How? Because we have 6 points. So carbon is here, carbon is here, carbon is here, carbon, carbon, carbon. But remember, our point of discussion today is going to be about naming. So whenever you are asked to name, how are you going to name? It's quite simple. But because it is in form of a shape, it is cyclic. So to name it, you always add a prefix. And the prefix you add is called cyclo. So that cyclo shows that what? It is cyclic in nature. That is, it is in form of a shape. Does that make sense? So suppose you want to name this now. What's going to be the name of this one? Or you can see this one. It is called cyclo what? Because you have 3 carbon. So you call it what? Pent. Cyclo, because of the cyclic. Sorry, it's not pent. It is prop. Because it is 3, you call it prop. And because everything contains single bond, remember, what do you add to it? ANE. All right, so let's take this one for example. You should be able to name this. What is it going to be? Don't forget to add cyclo. Why? Because it is in form of, it is in shape. Good. Then after that, how many carbon do we have here? Of course, we have 4 carbon, so you call it boots. Then everything here is single bond. Single, 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 single. So you add A and E to it. So it becomes cyclobutane. Now, suppose you are given this compound to name. What are you going to call it? The first thing, the prefix you must always add to it is what? Cyclo. How many carbons do we have here? Of course, here you can see we have 6 carbons. So you call it hex. And then you add ANE to it. Does that make sense to you? Perfect. So now let's take some more examples. What about if you have a compound like this? What are you going to call the name? We just did it. What do you call it? We call it cyclo. Why? Because it is cyclic in shape. Then what again? You call it hex because it has 6 points, 6 carbons. Then you put ANE to it. It becomes cyclohexane. Then how about if I put a substituent here, a methyl? What are you going to call it? You know that this methyl is a substituent, a prefix, an attachment. So you call it methyl. Why? Because it has 1 carbon. An attachment with 1 carbon is called methyl. Interesting. Perfect. So now, since you have called this methyl, remember in your rule of naming that we have done in our previous videos, we said if you are naming, after you have selected your parent chain, and this is our parent, this is our substituent, what else would you do? You are going to number. So you start numbering from here. 1. You can decide to go clockwise or anti-clockwise. There's no rule to that one. So far, there's only 1 substituent. You just name number 1, 2, 3, 4, 5, and 6. So what's going to be the name now? Methyl is as position 1. So you just say 1 methyl cyclohexane, and that's the name. Does that make sense to you? How about if you have a compound like this? So if I have a methyl here, CH3, and I also have a methyl here, what's it going to become? Of course, you number this way. Now it is going to be 1, 2. You cannot number the other way around. Why? Because if you are numbering the other way around, this one is going to be sticking 6. And remember that you always follow the lowest low count rule. So by default, it is better to number this way. 1, 2, then this space 3, 4, 5, then 6. I want to believe it is clear. Good. Now, after numbering, you can now see that this is a methyl at position 1, and there is also another methyl at position 2. How are you going to name it? You just say 1, 2. That is the position. Position of what? Methyl. But how many methyl do we have here? We have 2 methyl. So you need to show it that it is 2. So you say dimethyl. The word di here means what? 2. So 2-methyl dimethyl what? Cyclo. Don't forget, you must always add the word cyclo in order to show that it is in form of what? A ring. Good. Then hex. Everything here is single bonded. So you say cyclohexane. Does that make sense to you? All right. Interesting. Now, suppose we have another compound like this. So let us still put our methyl here, CH3. Let us say here you have CH2 and you have CH3. So what if you are asked to name this? How are you going to name? Oh, you want a number like this? 1, 2. No, that's very wrong. Why? Because this, look at this. This is a special rule. For each of the examples I'll be giving you, I'll be giving you rule with it. Okay, let us put it here. So suppose you have this compound like this. So here you have CH3. And here you have CH2, CH3. And you are required to name. Now, how are you going to name this? To name this is very simple. Remember that here you have more than one substituent. Here is a substituent. What's the name? We call it methyl. And here is another substituent, another prefix, another attachment. What is the name? This one has 2 carbon. So you are going to call it ethyl. So if I ask you here now, how many attachments or how many substituents do we have here? Of course, 2. This is the first one and this is the second one. Whenever you have more than one substituent, if you want to number, you number with respect to the alphabets. I repeat, whenever you want to number, if you have more than 2, if you have more than 2 substituents, numbering should be done alphabetically. So how do I mean here? If you want to number here now, because this one is E, you know that alphabetically E comes before M. So you start numbering from here. However, you don't go like this, because if you are going like this, it's going to take higher number. So you number like this: 1, 2, 3, 4, 5, and this place becomes 6. Does that make sense to you? So now you can see that ethyl is going to be at position what? Of course, carbon 1. And this methyl is going to be at position what? Position 3. So how are we going to name it now? Of course, it's quite simple. This becomes 1 ethyl. After that, the other one, which is what? 3 methyl. Then what? Cyclohexane. Why do we say it is hexane? Because everything here has just single bond. I want to believe it is clear. That is another that rule like that. Now let us take another example. Suppose you have a compound like this, and you also have another compound like this. Now, if you're asked to name, how are you going to name? You can see that this is an attachment, and this attachment, there's a carbon here like that. This attachment, there's a carbon here, there's a carbon here. So this one has how many carbon? Of course, you can see that this guy here has how many carbons? It has 2 points. So you see that it has 2 carbons. And if it has 2 carbons, since that it is an attachment, you call it ethyl. This one has just 1 point. So yeah, what do you call it? You call it methyl. I want to believe that is very clear. Now, if you want to name, how are you going to name? Remember that you need to number. And for you to number, you number from here. Because you have more than one. Remember, whenever you have more than one substituent, how do you number? You number with respect to the alphabet. So this becomes number 1, number 2, number 3, number 4, 5, and then 6. So how are you going to name? It's quite simple. It is the same thing as this. So you just say 1-ethyl, right? Then 3-methyl. Don't forget, whenever you are writing number and letters, you differentiate with the use of hyphen. Hmm? So 3-methyl. After that, cyclohexane. Why is it hexane? Because you can see now, it's quite simple. You can see now that everything here has single bond. That is that about that. You can see it's quite simple. So all you need to do is just follow through the course of the class and practice. The more you practice, the better you become. That's the logic. All right, let's take another example. Suppose you have a compound like this. And then you have, let's put something here. So here now, you can see that this one, this is a point, this is a point. There's a carbon here, there's a carbon here. This one has two carbon. This one, there's a carbon here. This one, there's a carbon here. No, this place is not meant for this attachment. This place is meant for the compound itself. Do you understand? So this point here is for the compound itself, carbon of the compound. There's a carbon here for the compound, for that cyclo. There's a carbon here for the cyclo, for the parent chain. There's a carbon here for the parent chain, the cyclo. And which cyclo is this? It has five carbon. So you call it what? Cyclopentane. But before we go ahead and say cyclopentane, what's the name of this attachment here? Of course, you can see that it has two what? Two carbons. You call it what? Ethyl. This one, what is it? You call it methyl. How about this one? It is also methyl. I want to believe it is getting clearer. Perfect. So now, you can now recognize that we have how many attachments now? We have three attachments. You can identify the three attachments here. Methyl, methyl with one ethyl. How are you going to name this? It's quite simple. We have more than one attachment. So you want to say you want to follow it alphabetically, Abi? No, you don't follow it alphabetically. Though you are supposed to follow it alphabetically, but because you have one carbon, this carbon here has two attachments. So whenever you are naming and then you have a carbon that has more branches or a carbon that has more attachments, you start numbering from the carbon that has more attachments. So that's another rule. Start numbering from the carbon with more attachments. So because this carbon here has more attachment than this carbon here has just one attachment, and that is ethyl. But this one has two attachments. It has two methyl that is attached to it. So by default, you start numbering from that place so that you can get lowest locant row. Do you understand? So this is going to become carbon 1. You don't go to this place because if you go like this, it's going to make it So this one will be 2, and this place will be 3, 4, and then 5. So if you want to name now, how are you going to name? It's quite simple. All you need to do is name the position first. The position is what? 1, 1. So sorry. No, we follow it alphabetically. So you are supposed to name the ethyl first before we go ahead and name the methyl. Remember, we follow it alphabetically. The only reason why we are not following the numbering alphabetically is because we have double attachment at this point. So now, if you want to name this one now, what are you going to say? You first name this because of alphabetically. E comes before M. So this one will now be 3-ethyl. After that, 1, 1-dimethyl cyclopentane. Why is it pentane? Because it has what? It has what? Only single bond. Perfect. How about if I have a compound like this? What's now going to be the name? What's the name of this compound? If I have a compound like this, it's quite simple. What are you going to do? All you are going to do here is just number your compound. But remember that inside this compound, we have what? Double bond. So this is going to be carbon 1, carbon 2, carbon 3, carbon 4, and then carbon 5, right? Perfect. Now, if I want to name this now, what am I going to say? I will just say cyclo. Why am I saying cyclo first? Because there is no attachment here. Cyclo what? How many carbons do we have? We have 5 carbons, so you call it pent. But am I going to say pentane? No, because we have double bond. So you say pent. Pent what? one in. Why is it one? Because the double bond is between carbon 1 and carbon 2. And you take the what? The smallest number. Remember, when you have two numbers, you consider the smallest over the what? Largest. Now, let's take another example. Suppose we have a compound like this. We solve more examples. The more the example we solve, the better it becomes. So let's say we have a compound like this, and then we have a double bond here, and we have a functional group here, OH. Now, how are we going to name this compound? It's quite simple, very, very simple. The first thing you need to remember here is that we give priority in numbering. We always give priority towards functional group. So how are we going to number it? You start your numbering from here. This becomes 1, 2, 3, 4, 5, and then 6. Now, since we have been able to number now, what is the next thing? You just go ahead and name. Is there any attachment here? There's no attachment. The only attachment we have is functional group. So there's no attachment. So we can go ahead and say what? It is cyclo what? How many carbon? Hex. Is it hexane? No. Why? Because we have double bond. And double bond is between carbon 2 and carbon 3. So we take 2 in preference to 3 because 2 is smaller than 3. So we say 2. What is 2? In. Then after that, what is the next thing? The functional group. We say 1 all. Why do we say 1 all? Because the functional group is at what? Position 1. And remember what we said in our last video. We said whenever you have two vowels coming following each other like this, what's going to happen? The previous vowel will be cancelled. So here now we are going to cancel the what? E. Why do we cancel the E? Because of this ON. This O is going to make us cancel the E. And then that's the name of that compound. I want to believe it is becoming more clearer. Perfect. So now let's take another example you could be presented with in your exam. What about if you have a compound like this? I have been using hexane. Let me use another one. Let us use 4 carbon. So if we have a compound like this, and then here we are asked to name, what is going to be the name? It's something that we need to be careful of. Remember that here, let me use this color. This one, this point, we have a carbon that is made for this cyclic compound. We have a carbon here made for the cyclic compound. We have a carbon here, and we also have a carbon here. This 4 carbon is made for the cyclic compound. So that this cyclic compound is what? Cyclobutz. Why did I say boot? Because of it has 4 carbon. But you see this branched. We have carbon here, carbon 1, carbon 2, carbon 3, carbon 4, and then this one is carbon 5. Recall from our simplest rule of naming. What do? Your parents must always contain the highest, the parent chain must always contain the highest carbon, that is the longest carbon chain. So because this one has the longest carbon chain, this is going to become the what? The parent. And if this one is parent, we cannot have two parents in organic compound. Unlike human being that we always have two parents. Here in organic compound, we have just one parent, and this is a parent. If this one is parent, this one is going to become what? The son, or just call it substituent. So if I want to name now, how am I going to name? Remember, before we can name, we need to number. So this one becomes carbon 1. This becomes carbon 2. Why am I numbering from here? Because that is where the attachment is. So we number from that point of attachment in order to follow the lowest locant rule. I want to believe it is making much more sense. Now, if I want to name now, how am I going to name? Remember, we always name our substituent, our prefix first. But to name the prefix, we start from here, from the position of the prefix. And this prefix here, this shape here, is attached to what? Carbon 1. So we say 1 cyclo what? Butyl. Why is it butyl? We are adding YL because it's an attachment. Remember an attachment. Example is what? Alkyl. So this one is going to be like an alkyl. So we call it cyclobutyl. Then we go ahead and name the parent. What's the name of the parent? The parent has 5 carbons. So we call it pentane. Why is it pentane? Because it has single bond. That's why we are ending it with ANE. Suppose it is double bond, it will be what? ENE. Oh, let's take an example so that it's going to be. Suppose we have an attachment here. Let me use another color for that attachment. Okay, let me put double bond. So if you want to name this one, now what's going to be? Of course, it's simple. Remember that we have one carbon here. We have carbon here, carbon here, carbon here, carbon here, and carbon here. Making how many carbons? For this cyclo, it is 6 carbon. There are 6 carbons there. Then here we have carbon here. For this branch, carbon is here and carbon is here. This one, there's no carbon. The carbon here is for this cyclo compound. Please, the cyclic compound. Take note of that. Now, which one is going to be our parent chain? Our parent chain, oh, you want to say is this one? Of course, yes. This one looks like a parent. It has appearance of a parent, but it's not going to be a parent. This one is a parent. And the reason for that is because of this double bond. The double bond cannot be an attachment. The double bond would rather be a parent than to be a substituent. Rather than being an attachment, it will be a what? Of course, it is going to be the parent because of this double bond. So the double bond here makes this one parent. This one, the example we did here earlier, this was the parent because of what? It is longer than this. It has longest carbon chain. But this one is going to be the parent here because of this double bond. Do you understand? Perfect. Then this one is now going to be a substituent. Even though this one is having, this substituent is having more carbon because of this double bond. Double bond has more power compared to the number of carbon. Now we can go ahead and name. How are we going to name? We already know our substituent. This is our substituent. It is attached to which carbon? How are we going to number? You want to number from here? No, you don't number from here. Remember that we are giving priority to what? This double bond. So we number from here. 1, 2, 3, 4. That is it. So now we can see that this compound here is attached to which carbon? Carbon 4, fourth carbon. So if we want to name now, we say 4 cyclohexyl. Why is it hexyl? Because it's an attachment. And then what is the parent? The parent is what? 4 carbon. Carbon 1, 2, 3, and 4. So we call it but. But what? We have double bond. Don't say in. It is going to be in. And that in is at position 1. That is the name of this compound. Is it making sense? All right. So if it is making sense, let me give you this compound. Quickly name it. Now name this compound and drop your answer in the comment section. Let's see your answer. Suppose we are given this question and then we are asked to name. How are we going to name it? It's quite simple, right? Now let us quickly identify the attachment. This is an attachment. This is an attachment and this is also an attachment. Making how many attachments? Of course, there are 3 attachments. This one you call it, because of there's just one carbon, so you call it what? Methyl. You should be used to all this name already. This one is also what? Methyl. And what is the name of this one? We call this what? Ethyl. However, we need the position where each of them are found. But recall that we have double bond here. So if you want to name, how are you going to name? Suppose this double bond is not here. Where are you going to start numbering? Sorry, if you want to name, where are you going to start numbering from? You're not going to start from this EO. You start from this methyl. Why? Because it has more attachments. But because of this double bond, you give preference. Whenever you are numbering, you give preference to the double bond. And how are you going to number? You number from here. This is going to be 1, 2, 3, 4, 5, and then this needs to be 6. So this our ethyl is at which position? 6th position. Methyl is at 3rd position, 3rd position, and this one is also at 4th position. Then this double bond is at the 4th position. Now let's go ahead and name. So how are we going to name? You start by alphabetically, don't forget that. So this one will be 6 ethyl hyphen 3,3 dimethyl what? We are done naming the substituent, so we can go ahead and name the parent now, which is what? Hex. Hex what? We have double bond. You cannot say hexane. So you say what? It is 1 in. So simple as ABC. Now let's take another example. Suppose you are given this type of compound and then you are asked to name. How are you going to name? This is also very simple. So you don't need to disturb yourself over this. Suppose, okay, let me put double bond here with oxygen, and then let's put OH here. Now, since you are seeing double bond with oxygen and OH, what does that represent? And remember, we have carbon here. What is that going to translate? It translates as COOH. And what is COOH? That is the functional group for what? Arachidonic acid, carboxylic acid. So we always end it with what? Oic acid. Remember that? Perfect. Now, This place there's also going to be carbon. This place there will be carbon, and right here there's going to be carbon, which is meant for the what? The cyclic compound. There's carbon here for the cyclic compound, and here also there's carbon for the cyclic compound. Now, if I want to name, how am I going to name? Because of the functional group here, just like the way I did for the double bond earlier. So because of the functional group here, this one becomes the parent automatically, even though it has just 3 carbon compared to this, which is quite larger. However, this one is going to be parent over this. Reason because of the functional group. And what's the functional group? The oic acid, the arachidonic acid there. So now, if I want to name this now, this one is going to be the what? The substituent. So naming this is quite simple. We start by naming the substituent. And what is substituent? Cyclobutyl. So the cyclobutyl here is going to be the substituent. And then we can now go ahead and name our compound. So the cyclobutyl is at which position? Don't say first position. You number from here. This is carbon 1, carbon 2, and then carbon 3. So this becomes what? 1. Sorry, not 1. This becomes 3. Why is it 3? Because this substituent is attached to third carbon. So we say 3 cyclobutyl. That's the attachment. That's the name of this guy, cyclobutyl. And how about this one? It is pent. Sorry, not pent. Prop. Why is it prop? Because of 3 carbon. So 3 is represented with what? Prop. Prop what? We have single bond. This is single bond. This is single bond. This is single bond. Oh, you are thinking this one is double bond. Yes, this is double bond. But we only take the double bond between carbon to carbon. This is not a double bond between carbon to carbon. So you cannot call it in. Before you can say something is in, you must see double bond between carbon to carbon, not carbon with other elements. So if you see carbon with oxygen like this is not going to be in. Do you understand? It is not in. You are not going to count it. So this is still going to be what? A-N-E. Why? Everything is single bond. Then 1 oic acid. But remember, O is here. This O is going to cancel this. So what are you going to call it? Yes, we call it propan 1 oic acid. And that's the name of that compound. It's quite simple, and yes. So let me quickly give you an assessment. So drop your answer in the comment section. Name this compound. Remember to like, comment, and share so that you can get more, so that you can get notification whenever we post any new content. We meet in our next video. Bye for now.